I think the video cut us off right at the end here, so I want to make sure everybody is good. So, when we had a true statement, true means infinite solutions. If you're just solving one equation, we say all real numbers. But when we're solving two equations, it's infinite solutions because it's all the points they have in common, because one line is going to graph right on top of the other line. So all those points they have in common will be considered solutions. And I just picked this equation, so infinite solutions on the line x plus y equals 7. You could have used this. This one's just a simplified version. And because one line graphs on top of the other line, those two lines are dependent on each other. So we say the system is dependent. Okay, so if it's a false statement, I'm going to get my dog out of here. Let me finish this real fast. If it's a false statement, then we write no solution. If it's a true statement, we write infinite solutions. Okay, I'm going to pause just for a second. So go ahead and look at the first problem on page 13 and go ahead and start working that. I was going to give you guys time to work it on your own anyway, so let's do it. This would be a good one for you to practice on. Well, it's actually, I can tell, going to be a little bit of a boring one, but at least there's some work at the beginning for you to practice on. So go ahead and work on 6, and then we'll come back together and check it. So first, for number 6, we need to distribute, just like we do with other equations. So we get 3y minus 3x minus 2y. So 3y minus 3x minus 2y equals negative 3. So let's go ahead and get this one ready. So these two are like terms. The x has to be out in front, so it's going to be negative 3x. 3y minus 2y would be plus 1y equals negative 3. So that one's all ready to go. It's in standard form. It has x and y in alphabetical order on the left, constant on the right. And then this one's going to be 3x plus 3 equals y plus 2. So there's two problems with that one. All the constants aren't on the right, and all the variables aren't on the left. So first, let's move this constant over. So that's going to give us 3x equals y. 2 minus 3 is negative 1. So now I have my constants on my left. I have my x on the, my constants on the right. I have my x on the left. Now I need my y over there. So minus y. That's gone. So we get 3x minus y equals negative 1. So minus 1y. Oh my. Now that was a different little problem, huh? So look at my two equations. X's cancel, y's cancel. So what do you think I have left on the left side if both of those cancel? I have to have some number. What's 3 minus 3? 0. So you can't leave a side blank ever. If everything cancels, then there's just 0 over there. And negative 3 and negative 1 would be 0 equals negative 4. True or false? False statement, right? So guess what that means? False means the two lines are never going to cross because the answer is no solution. False is always no solution, whether you're solving one equation or a system. False always means no solution, but in this case, the only way to get no solution, because remember, solution is where do the lines cross? What point do they cross at? Well, if they never cross, the only possibility is they're parallel. Okay, so a false statement means there's no solution. The only way two lines can never cross means they're parallel. And remember, we call this inconsistent because this is not the normal case. Usually two lines cross somewhere down the line. So we just say it's inconsistent. So that was both of the special cases there for you to practice and look at. Okay, let's do the last problem on this page. So this one maybe will be more interesting for you to solve. So let's set it up together and then maybe we can solve it. You can solve it on your own because that one didn't give you any practice multiplying to make opposites or anything because they were already opposites. So that was a little bit too easy for you to practice on. So let's set this up together and then I'll let you guys practice solving it. Tony and Dee Dee, I see how many tickets did Tony sell. So that tells me to get my variables ready. T equals number of tickets for Tony. And we'll use D for Dee Dee. That way when we find our variables, we know exactly what it is we found. So number of tickets Dee Dee sold. And remember when we did one just like this on our last notes, it was money. And I said one's always going to be just about how much you sold, how many quarters and half dollars were in the jar. So it's just a number problem, no money involved. Then the second equation is going to have money, like how much did each of Tony's tickets cost? How much did each of Dee Dee's tickets cost? Just like with the quarters and the half dollars, we went 0.25 times Q plus 0.50 times H and set it equal to the money. We'll do the same thing on this one. So the first equation is just about a total. So if these two sold 27 tickets total, you'd say Tony plus Dee Dee's tickets equals 27. So the first equation's always the easiest because all you do is go, oh, they sold 27, so his tickets plus her tickets, 27. Then the next one is when we have to add in money. So Tony's tickets were $3. So $3 times how many tickets Tony sold. Dee Dee's tickets were $6.50, so plus $6.50 times how many tickets Dee Dee sold equals $105.50. Okay, so why don't you go ahead, turn off the video, get rid of your decimals, try to make opposites, and see if you can get the answer to this. And then turn your video back on and we'll check it together. Okay, so the first equation's perfect. It's all ready to go. But this equation, I'm not liking the decimal places. So the zeros don't really count. So I really only need to multiply by 10 because the zeros are just there because it's money. So I can multiply this by 10, this by 10, and this by 10 to get rid of the decimals. Only because zeros are on the end. So it would really be 65 tenths, 1,055 tenths, because the zeros are only there for money purposes. So this first equation is going to stay the same. T plus D equals 27. And the second equation is going to be 10 times 3, 30, T plus, move over one place, 65D equals 1,055. So I just moved all the decimals over one. So 3 turns into 30, 6.5 turned into 65, and 105.5 turned into 1,055. Okay, so everybody with me how we did that? Okay, so next we need to make opposites. So we have two choices on this one. This t is 30. We could easily make this one negative 30 by multiplying the whole numerator by, or the top equation by negative 30. This is 65. We could easily make this negative 65 by multiplying the whole upper equation by negative 65. 30 is a little smaller, so let's pick that. And if this is 30, remember I need this to be the opposite, which is negative 30. So we're going to distribute negative 30 and get a new equation to add on to this. So that's going to be negative 30t and negative 30d and negative 810, I believe. But let's check it out. So negative 30 times 27. Negative 810. Good. So we'll keep that here because we're going to need it. So then before we add our plus sign, we look down the line and say, do we have opposites? 30 minus 30, yes we do. So eliminate the t's because 30 minus 30 is 0. Then we get 65 minus 30, which is 30d equals negative 810 and positive 1055, which is 245. This is not looking good because negative 30t, negative 30d, negative 810, 30t, 65d, 1055. 65 minus 30 is 30 because this is not going to go in evenly. Somewhere there's a mistake. Let's find the mistake. How did I know that? Because I know the number of tickets Dee Dee sold has to be a whole number. So the minute I see that, I go, okay, wait a minute, something's going wrong here. So did I write the equations right? 27, T plus D is 27, $3 for Tony, $6.50 for Dee Dee. Total was $105.50. Then I multiplied everything by 10, so that stayed the same. So 30t, 65d, 105.5. And then I multiplied all this by negative 30, so negative 30t, negative 30d, negative 810. Oh, I see my mistake. I subtracted wrong. So anytime you catch something like that and go, wait, we can't have a decimal number of tickets, go back and look at that. So 65 minus 30 is 35d. So now we divide both sides by 35, 35, and we get d equals 245 divided by 35, 7. So Dee Dee sold 7 tickets. But the question wants to know how many did Tony sell? So it's real easy to tell. So we say, well, we know they sold 27 total. So if Dee Dee sold 7 of them, that means Tony sold 20 tickets. And that's your answer. Because she sold 7, so take